can become comfortable with simulation operations, it will make your work faster. One thing I noticed is that we forgot to properly set the time step for the unsteady solver in solid region, or at least I had set it incorrectly at first. For the unsteady solid solver, the time step should be 0.2 seconds. If you leave it at the very small default value, the simulation will take much longer than necessary and you'll waste a lot of time solving the solid region without any real benefit. Now I'll click on the scalar temperature scene. As you can see, we have 10 coupling iterations. We can see the temperature distribution inside the manifold, and how the temperature field has evolved over time in the solid and the fluid. Using this exercise, we looked at heat transfer and, more specifically, conjugate heat transfer. We saw how to define fluid-solid regions and how to solve them together. We learned how to set up interface between fluid and solid so that information is exchanged correctly. We talked about conformal meshing and how to get matching meshes across regions. We went through some useful tips like how to turn plots into annotations, and how to add those annotations into a scene so your post-processing is clearer and more professional. The most valuable parts, in my opinion, was the section on simulation operations. If you can become comfortable with simulation operations, it will make your work faster. Any time your boundary conditions or setup change, you won't have to redo everything manually, you can just rerun the operations with small adjustments, instead of spending a lot of extra time repeating the same steps. I hope this training series, as a whole, has been useful for you. I've tried my best to make it comprehensive, starting from very basic concepts, and gradually moving all the way up to some of the most complex and advanced physics that you can model in StarCom+.